Hello, everyone. Welcome back to Advent of Code 2022. Here in still March of 2023, I think. Certainly at the time of this recording, but I don't know exactly how far of backlog I have of these. Anyway, it doesn't matter. We're gonna get started on day 11, but first I had one small improvement I made to day 10 that I wanted to point out, which is just that I used this magic number 40 twice with really no explanation at all. Um, and I don't know. I guess really 20 should be extracted as well, but whatever. I guess I'm not going to. Because 20 is just sort of like, that's what the problem says. It doesn't tell you why to pick 20, right? There's not a name I could give this. It'd be, number required by the spec is 20. Not very instructive. Whereas pixels per row, that means something. So I extracted that out to be a constant here, to make it a little bit clearer why we're going through everything in groups of 40. So that's all I had to say about that. Let's give that a commit. Just the day 10 stuff, please. What do they call it? Pixels per row? Yeah. Cool. And that's all I had to say on that. Let's check out day 11. Monkey in the middle. As you finally start making your way upriver, realize your pack is much lighter than you remember. Just then, one of the items from your... Oh, this is the one that I saw because someone asked a Stack Overflow question about it. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. You take some notes, your puzzle input, on the items each monkey currently has, how worried you are about those items, and how the monkey makes decisions based on your worry level. For example, we've got a lot of parsing to do here. But it's very regular, right? It's exactly 5 rows. The first row is always blah, the second row is always blah, and so on. So monkey starts... So items are measured, like, we're just working with numbers, and they've decided to describe those as items measured by their worry level, but all that really matters is their numbers. Your worry level for each item the monkey is currently holding in the order they will be inspected. So monkeys are looking at these items. Like he has an item 79 he'll look at first, then item 98 he'll look at next. Or not the 98th item, but an item whose magnitude is 98. Operation shows how your worry level changes as the monkey inspects an item. So these are all given in, new is old and then some operator, and either times, either old or another number, I guess. Then so they always handle it and change my worry level according to this formula. And then they perform a divisibility test on the item to decide who should get it next. So they always give it to someone when they're done inspecting it. I think in principle a monkey could throw to itself, but I don't think that ever happens. Maybe it does. I don't know. After each monkey inspects an item, but before it tests your worry level, so we apply the monkey's operation and then divide by 3 and then do the test, I think. The monkeys take turns inspecting throwing items. On a single monkey's turn, it inspects and throws all the items it's holding one at a time in the order listed. and that's at the start of its turn. So like if monkey 0 throws an item to monkey 1, then monkey 1 will inspect that item during that round. It's not like they all do all their operations simultaneously or something. Yes, a monkey that starts a round with no items could end up inspecting many items by the time, because someone gives it stuff. If it has no items when it turn starts, it does nothing. Sure. So I think I understand this operation. Chasing all the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of times each monkey inspects items over 20 rounds. And then find the 2 who have inspected the most times and multiply them. Okay. So I want to show you the Stack Overflow question about this, because it's not a particularly... Well, actually, before we do that, let's look at the input. And grab this and put it into my text file. Okay. You didn't actually see me paste it, but I promise I did. So if I look at my Stack Overflow profile, how do I search for answers, newest, activity? Squaring a very large big integer is very slow, is a question somebody had. So they were working on this in Closure, day 11, part 2. So I am a little surprised that this problem didn't come up on part 1. Oh, it's just, right. You simulated a larger number of rounds in part 2, right. If we look at part 1, it says go over 20 rounds. I believe part 2 is like simulate 10,000 rounds or something. So this person defines a monkey, a function to make monkeys, a function to add to a monkey's thing. What, they're updating items. How are they creating a monkey? A queue, I assume, right? I don't see any queues, which is a little bit weird. Oh, here's the test code. No, they're just making... Oh, they're putting it all at the end, and then there's... Okay, sure. Okay, I guess. And then they seek over it. That actually probably works fine. Anyway. And the problem is, one of the monkeys here is multiplying a number by itself. We saw that in the example, and it should be in our test input as well somewhere. Old times old, I assume. Yeah, here, monkey 7, right? Old times old. So, the problem is that if you do 10,000 rounds, where in some non-trivial percentage of those rounds, you square a number and then reuse that number later, you end up like squaring a number many times, and that creates actually super exponential growth, which I was a little surprised to see. I thought it would just be exponential. Now, there's some dividing by 3, and it isn't always the same monkey doing something, so it won't actually be 10,000 times. But this person was like, this is kind of slow. I tested it, and it got through, after about 200 iterations, it starts getting slow, and I thought maybe it would take a few days to finish. And it's like, no, this is an example of how bad people's intuition about exponentials is if you haven't dealt with them a lot of times. If it's slow around 200 and you're measuring an exponential process, 10,000 is not a couple days from now. It's like after the universe ends. But fortunately, as I point out, the time is not actually a problem. Someone commented a small optimization that could be made here, which might speed your program up by as much as like 10, a factor of 10 if you were very lucky. But that is not nearly enough, as I detail here. So the problem is you have an exponential running time, and you're you're iterating on x equals x times x many times. And suppose you started with 2 and ran this 10,000 times. 2 squared is 4. You square that, you get 16. You square that, you get 256. And so notice that it's not that the number itself is growing exponentially. That would just be 2, 4, 8, 16, 32. But rather the exponent itself is growing exponentially. 1, 2, 4, 8. The next one would be 16, and so on. And so we're computing 2 to the power of 2 to the power of 10,000. So, to store the number 2 to the 10,000 takes 10,000 bits. Not all that many. Now, doing math on it would be very slow. But to store the number 2 to the power 2 to the 10,000, you don't have even close to enough atoms in the universe. And so I don't know. I love when people ask questions. They're like, how do I do this? And I can say, actually, what you're doing would require more atoms than there are in the universe, so you should find another approach. And here, yes, there is that is such a case, and the improvement to the approach is not very difficult. You just can't store the whole number. We can look at, so what we're being asked in each of these monkeys, nobody ever asks us, what is the worry level of this item at the end of the process? They ask us, how many times does each monkey touch each item? And the monkey's decisions are not based on the magnitude of the number either. They're only based on its divisibility properties. Which means you could work in modular arithmetic, and you would still have all the right divisibility results. And then, of course, all the operations would be much faster, and you would need smaller numbers. Now, there is one potential hitch that could exist, which is that most things are pretty efficient in modular arithmetic, because you just do the normal math and then you take a modulus. But one thing is way harder than more than one thing. One of the things that is way harder in modular arithmetic than normal, and this is like the foundation of cryptography, one of them anyway, is division. You can't really compute, what is 13 divided by 2 mod 7 or whatever. It's just very hard. Or, I don't know, for 2 it's probably easy. But if you pick 2 relatively prime numbers, the division is just really hard to do. And you end up basically just having to try all the possible numbers. But fortunately, no one is ever asking us to divide numbers, right? We have to multiply, add, multiply, add, and square. And we have to do divisibility tests, but that's not division. That's much easier. So, the point is we need to work in modular arithmetic here. So, we need to parse all the monkeys. We need to figure out what's the word? Is it least common divisor, right? No, least common multiple. Of all of our divisibility tests, and that's the modulus we have to work in so that we're not disrupting any of them. But I think these are all prime, right? Yeah, 70, no, that's 17. I thought it was 71. Yeah, 17 is definitely prime. So we can just multiply them all together. 17, 3, 5, 7, 11, 19, 2, 13. Those are all prime and therefore coprime, and so their least common multiple will just be their product. So that's the overall plan of attack I have for this, is just use modular arithmetic, and then do exactly what this says in the obvious way. But we have some modeling to do. Okay, so let's start. Do I need anything from lib? All it really has is coordinates, and we don't need those. Of course, reading input, which we will do. But no, so we will be defining all our types from scratch here. Data. So what do we have here? We obviously need a monkey. Data class. I had just typed data. I'm so used to Haskell. You have to say data class. Monkey. It contains many vowels. I don't think they need to know their own number. We'll just put them in a list and look them up by number, so that's fine. It needs to have a queue of items. Items is a queue from, I guess, Java util. Hang on, no, wait. This is one of the old super cursed class, isn't it? Oh, no, it's not. No one ever uses this, though. They use dec, array dec, right? The double-ended queue. So why does this exist? Huh. Oh, the problem, of course, is that this is just an interface. We need an implementation. Sure. So this is a queue of item, where really I think an item is just going to be an int. I mean, why did you... I'm surprised you didn't have the option to make it a type alias, right? Type... Oh, what I could do is say int here, and then later I could extract a type alias for it, right? Yeah, okay, cute. I think we just want a queue. Additionally, we need an operation. Operation, which is a function from item to item. Is that? Oh, these are supposed to be ints. Okay, fine. I'll use item now. I'll define the type alias now, just so I don't get confused about what kinds of ints are what. Type alias item equals int, right? Okay, is this not how you... Val? There you go. Good. That is how you specify a function in a signature. What else do we need? A divisibility test. We'll make that an int because it's not an item. And then an if true and an if false. Let's just call this factor. Let's find another type alias here. Monkey index. That's also an int. This should be a colon. Val not divisible is also a monkey index. Cool. My first class that's got enough stuff that I needed a new line for its constructor. Amazing. So, well, it's a little bit like, is monkey index really useful as a type alias if, like, we're going to just put them in a list and look them up by int anyway? Oh, I remembered something, by the way. A while ago, I was confused about type aliases and how it seemed like in one day I had used one and I needed to use like the new type constructor to convert from an from an int to an item, and then like in a later one it said you can't do that. You have to just use the underlying int. I realized why. It was because I was confused in the first case. I had defined something as a new type or a type alias for pair, and when I did that, it changed me from calling the pair constructor to calling the assignment constructor, I think it was. And those are the same type, so it's the same constructor. If I had had a pair, by calling like pair of AB, it would have been illegal to wrap that in the imaginary constructor assignment. So that was why I was confused. Anyway, so there is no conversion between things with type aliases. If I wanted to, I could use a data class for like real, like compiler protected type aliases, but I don't think I will. I just want these to be given clearer names. Clear types. I don't know. So that's our monkey type. And I think we just want to write a parse function now that makes a monkey, right? Except I don't know. It's a little bit awkward to process a list of lines, maybe? Would it be better to process just a single giant string? Maybe. But I guess I can just take the list of strings and say I want it in chunks of 7 to include all of this. The last one, I'll even put in the new line so it actually has an empty line at the end. And then I can just parse the lines by index. Yeah, that seems fine. So let's write parse takes a list of strings, I think. We're going to give it the whole list all at once, and it'll... Or no, it'll... Yeah, let's say parse monkey, which takes... I mean, really, it should take a 7-tuple of strings, but I don't think that's a popular way to do things in Kotlin or a very ergonomic one. Takes a list of string and returns a monkey. Oh, I should name the variable, huh? Can I destructure here? No, right? Return null? Why are you... There is a body. It's right there. Can you not see? Let's say add function body. See what... Okay. I don't know what it thinks this is, but it thinks this is a function. So clearly, no, you are not allowed to destructure it there. We can say val... I assume we can destructure strings? I could just do it by index, but I don't want to. Index items operation test if true, if false is lines. That's allowed, right? No. Lines are not destructurable. Also, I was wrong. It should have been ignored. Like this. Well, maybe you can just say as something? As? Sequence? No, of course not. Lines dot destructure? No. All right. Tuple? No. That's fine. I guess we will just say, let's just return monkey of first is, we're going to ignore the monkey number. Parse items of lines 1. Parse operation of lines 2. Parse factor of lines 3. Parse if true. I should just call this if true, right? Lines 4. Parse if false of lines 5. And I think that covers all the things that the monkey is supposed to have, and we have the right index of them all. We have to name or define all these functions now, but that's fine. Sure. Turns it made a queue of item. That's so nice. Usually it's like whenever I say to use a type alias for something, it like just uses the underlying type when auto-completing or defining new things, and I don't know why. But this time it did it right, so great. Let's just make all these to-dos. Okay, I see that I should have defined them from the bottom up because of the order it's going to define them, I guess. Oh, did I? Okay. Let's just delete all this so I can do it from the bottom up. Yes, create. Cool. So now I have some parsing to do, but if I were done parsing, I'd be done parsing. That's cool. Parse items. So what do items look like? Pretty simple. Const val items is regex. God, I'm going to have to use split as well. I hate doing this. I wish I had a real parser, but I don't know where to find them in Kotlin, and it's, I don't know. I'm sure it's not as much fun to use as Haskell's. Because they don't have currying. You need currying and applicatives and stuff to do all the cool parsec nonsense. Monads as well would help, but I don't need them here. So we're parsing starting items colon. I think we're just going to say dot plus because there's not really a great way. I mean, I don't know. I mean, I guess I could be a little more specific. Oh, let's... /d plus optional comma plus. Like, right? That way it matches exactly the whole line and only if it's well formed. This can't be a const, you're right. So we can say items dot match entire of s dot question dot be structured let items to items dot, I assume we have split or something. What are you upset about here? Redundant let call could be removed. Okay, you don't even know how to do it. I'm just not done. Give me a break. Oh, because it thinks this I'm doing this for side effects because there's a to-do here. Yeah, now it doesn't think it's redundant, or I'm just not finished. I don't know. Anyway, items dot split. Like, you know, items is a string, right? Oh no, I'm supposed to say this. There we go. It destructure it to get out the first match group. Now I can say split. What the heck is the difference between all of these? I mean, I feel silly using a regex that's just like comma space. What do var args even do? The specified delimiters. So you're somehow allowed to apply things multiple times or something? Can I look up uses of this? No. Okay, well, I don't... Split boolean int? What? Kotlin.text? Ignore case, defaults to default, limit defaults to 0. So I think split on and then just pass comma space should be fine. Let's look up what the deal is with Kotlin var args, shall we? Kotlin var args. How do you use those? Let me find you guys and show you this page. Functions. If I look for var arg, pass a variable number of arguments with names using spread. What the fuck? Okay. Weird. But I think I'm allowed to just pass one of them, right? I mean, I'm familiar with spread from, like, for example, Python and I think Ruby. Yeah, but Ruby calls it splat. Usually it's only for the last argument. Python can collect it in keyword arguments. I guess Kotlin has a way for each, for any named argument to be a var args argument, where you have to like pass an array explicitly to do that, or maybe you can pass a list. I don't know. So if I say items.split on this, like, is that legal? It should be, right? Yeah. Except I probably want to split to sequence. And then map it to yes, there won't be any commas, so a toInt is correct. I think that's it. No, but then I need to turn it into a queue. Dot collection. It takes a mutable collection. So I think an array deck from, I guess Kotlin.collections is fine, right? Like that. And then we just have to say, or else throw runtime exception. No parse s, right? Exceptoin exception. So let's just, oh, sorry, what's failing to compile here? Problems? A return expression is required. Okay, fine. It's, oh, an array deck doesn't implement Java utils queue, I guess? So I need to use a different one. This one? Okay. Cool. So what I wanted to do real quick is just test this in the REPL and make sure it parses okay. If you could finish compiling, that would be great. It's not a very complicated program, I don't think. Cool. So now I can say parse items of this, but without the new line, of course. Ah. No parse. Did I forget to write starting items? No. There are 2 spaces here. God, I hate debugging regexes. Because there's no inspectability at all. Oh God. Where do I even... Let's make sure I've copied this exactly. I haven't made some weird typo. Can't imagine that I have. No, still looks the same. I mean, I can also, like, test this regex, I guess, without having to open up the REPL. Does not match. Now that's actually quite interesting, isn't it? I put, like, a different number of spaces here. So apparently Kotlin... So the reason IntelliJ is warning me is not just because multiple spaces in a regex are somehow a mistake that it's easy to accidentally make a typo, but it actually has a semantic difference. Wait, I had multiples there a second ago. So tell me why this is a problem. I know I could replace it with 2. I mean, fine, I guess I'll do that. Is it because of how, like, these literal regex thingies work? No, this is still a problem. All right, whatever. So I'll just say 2. Oops, 2. And if I check this, I have to put 4 spaces in for some reason. What? Oh, did I not? What? Oh, I see. When I edited this, it actually changed the source here. That's why it got different somehow. That's so weird. So if I put 2 spaces in here... Oh, I forgot the space. Comma space plus. I should have edited it here. More example input expected. Oh, dang it. Bring it. Edit it here. This now is supposed to actually be in a non-capturing group. So the comma and the space together are supposed to be optional. Right. And now it actually matches exactly how I wanted. And just out of curiosity, if I put 2 spaces here, no, it says that's fine. It just thinks you shouldn't do that. I think I should. Well, I don't know. I guess it's like, it's fine. You know, it would be kind of nice to have these these line parsers not be responsible for trimming out the indent, right? If the top level thing was what was responsible for knowing about them, and I think we could manage that. If I said get rid of all this, and here if we said trim, does maybe trim just works? I was going to trim exactly, oh, trim indent. What does that do? Probably nothing actually good. Comment indent all the, okay, I mean, this still looks fine. Replace indent, how does this work? It searches all the lines, finds the non-blank ones. Indent, finds the indent width. Yeah, so I think it should work even for a single line. Yeah. All right, so we'll use that. And that's simpler. Sort of. It's going to be more characters, but also, I think, more clear. So let's check this regex one more time. There. As expected. All right. So if we rerun this, just to make sure it actually parses this function is right, not just the regex. Any second now. I hit Control Enter. Yeah. So it's wrong. Cool. Ah. Yes, this is wrong. The problem is I have a capturing group which captures /d+, and when I group it, when I ask what that group is, I just get like the last match or the first match or something. What I should have said was take this group and don't capture it, but wrap around the repetition operator an actual capturing match so that I get... Oh, wait a minute. Why do I need this capturing group at all? It's not doing anything? Yeah, it is. It's /d+. Yeah, it's fine. Good. Now we have a queue of the right things. Is it... Do I actually have it backwards? What order are we supposed to look at stuff? Inspects items one at a time in the order listed. So really, if we want to treat this like a queue, we should say what are the operations on a queue? Clone size, so I can say first and last. Does this have everything ArrayDeck has, basically? I don't think so. No, it has offer first, offer last, peak first, peak last, take first? What's it called? Poll? Poll first and poll last. Add first, add last. Yeah, this has everything we need. But I kind of... Oh yeah, in the order listed, right? So the one that's first in its list, as constructed here, is the one it will look at first. How do monkeys, when they... goes on the end of its list. So we'll add last when monkeys pass stuff to each other. Fine. Okay, cool. So we're finally done parsing items. Yuck. What does an operation look like? Regex of operation divisible by no. New equals, and do they all say old first? They do, right? We just have old op arg basically. Yeah. Will you say convert? Can you like fix the fact that I always forget to write? Yeah, raw string literal. Okay, thanks. So I think this is right. Old new equals old something, and either old or else a number. And we can just say return operation dot match entire s destructured let op arg to be a what did I say this is? Oh, a function. Sure. Val. I guess arg should be a function of x as well, right? Function of old. Val get argf, maybe? Or equals when arg is equal to old, then fun is there like an identity function? I mean, I want to put a lambda here, but I don't know how. So fun maybe if I specify a fun, if I give this a type, is a function from int to int. Why is this disallowed? I can't make a value that's a function, but I can specify it as a function parameter. All right, tell you what, I'll just write a fun here, and you tell me what type it should have. Fun. Is that even allowed? I don't know. X is an int to equals X. Type mismatch. Doesn't look that way to me. Oh, that should be equals, not colon equals. Item in parens arrow item? I don't understand what is happening here. Oh, the mismatch is in the return. Okay. I say null here. Wait. Did I mean to write it like that? Should it have been this? No, that's a nonsense type. Okay. What if I... What... So here, of course, I should throw runtime exception, no parse, like that. But now this doesn't return. No, it does return something. Argif? Oh, the problem is I didn't say I was returning this. I had it in val, and okay. When expressions must be exhaustive. Okay. Now, is it possible that here I can just say it? Yes, I can. Okay, good. Else it's, I guess, arg.toInt dot let n to lambda n. N to, or x, I don't know, to x. Okay. X to x or n to, I mean, this makes me feel a little uncomfortable. N to lambda that ignores its argument and takes an n. So let's say x. There you go. That's much clearer. Okay, sure. That's also fine. But I don't actually want to return argf. Argf was just one thing. I want also to say val op. Okay, let's return argf for now still, so it'll stop bothering me. Is when of op, if it's plus int plus. Is that what I want? I think so. Times int times. What else do I need? Is there anything? Times plus plus times plus 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 times. So that's all I need. Else no operator op. Oh, and here I'm shadowing op, I guess. Oh, that's a little dangerous. Op f, I guess. And so now I just want to return a lambda of x to op f of x and arg fx. Well, okay, yeah, so, I mean, I guess I'll write it out by hand if you want. This is xy, x plus y? Like, but you're still going to not know about resolution, right? Can't infer a parameter type. Fun. This is horrible. How do I specify this? Times? You still don't know. Yeah, I said autocomplete and you were like, yeah, that one. But it's still no... Oh, the problem is I haven't specified the type of opf, I guess. It's a function from... I guess item and item to item? Okay. Fine. That seems all right. So let's check this regex, I guess, with this as input. Great. And I want to say parse op of this is a function and apply the result to 9. That looks right. And the exciting one is when we say old times old, we should get 81. We do. Okay, great. All right, every one of these, I say the parsing is going to be easy, and then I just spend hours working through it for no reason. Like, there's always stuff that tricks me. So now we need to parse a factor. Val factor is a regex of much less error prone if I just copy the string as well. Divisible by d plus. No problem there. This, honestly, this one really can't take me long to parse, right? How could I screw this up? It's return s dot match and nope. Factor dot match entire of s destructured let. Yeah, let, that's right. D to D dot to it, I think. Throw runtime exception, no parse s, right? And really, this could just be an expression body. Like capitalized parse this time for some reason. Okay. I'm not even going to test this. What could possibly go wrong? Yeah. Okay. How about if true? Well, if true is... Well, it's kind of like... there's a little bit that I could reuse here, right? That would be a little nice. Let's just have this be... equals parse cond true s. All right, that's all I really want. And this is parse cond of false s. This should not return an any. I don't know how you got that idea. There you go. And now this can just say regex of some words and some digits. Now we want, I think, to I can't get the indentation to work. Return S1 and S. Cond is a string and S is a string. S dot match, not S. Cond dot match entire of S. Destructured let B N, like that. Now I want a way to say, like, if B is not equal to cond, then throw up, right? In real life, this won't happen because our input file is well formed. But it's the sort of thing that it would be nice to get right. And I'm not actually sure the good, like, obviously I could just write, like, if these two are not equal, then return at, well, actually, it would just return would be fine. I can throw an exception, in fact. But there's got to be some cute way to let that, like, cause the lambda to return null. Is there like, there's like a take if, right? So I think I can, yeah, let's say it's n.toInt take if, and I'll just completely ignore the argument. Gotcha. Take if B equal cond? Oh, that's why it wouldn't work. There's too many braces? No, that's not true. Or else throw runtime exception. No parse of S, right? So that actually looks pretty reasonable, right? You say a.toInt, but only if B is equal to cond. That seems fine. And I think we're done parsing. So this would be a perfect time to write a main function, except it should have parens. Val monkeys is read input of 11 dot chunked into sevens dot map parse monkey of it. And then we can say println of monkeys, right? Little program test, see if we parse the whole input file successfully. Yeah, we got a bunch of monkeys. They've all got cues in the right order. Ooh, I'm a little nervous about. Oh, this is fine. This is just saying it's a function of one argument, and its types are int and int. So in Java, you don't get these niceties because all of the the function types, just like I believe, they basically just print, they have no two-string implementation. So they just return like the type that, which is going to be some random lambda, foo $bar fun lambda, and then like it'll be at whatever. But this tells you, oh, it's a function of one argument from int to int. And okay, great. So the first monkey has 3, 0, and 3 as its thingies. Is that what we expected? Nope. Oh, that's the second monkey. I scrolled. The first monkey has 17, 5, and 3. Cool. So that's what we wanted. Let's just commit that. A small celebration, shall we? Day 11 types and parser, because I don't really think the rest is that hard, but of course neither was this supposed to have been, and here we are, however many years later. It got committed. Okay. So we want a function that simulates one round, right? That's what they call this in the spec. Process of each monkey taking a single turn is called a round, right? Yeah. So let's just write a function that runs one round, and then part one. And then we'll write a function that runs n rounds, and part 1 will do that 20 times, and part 2 will do it some larger number of times. Well, and then I guess at the end we'll have to select out the important information from it. That, I guess, means, I forgot about what we're actually supposed to be tracking all this time. Which is how many times each monkey has handled an item. Is that correct? Yes. So, regrettably, I think the best thing to do is to give monkey a mutable field. Like, yes, we could have a little, like, list on the side where we track how many times a monkey has done something. But that's kind of fighting against the stream here. In Kotlin, it's going to be way easier and more idiomatic to just give this a mutable field, right? Var, ooh. And we're going to have to copy all the monkeys, right? If we have this mutable field, then part 1 and part 2 are otherwise going to step on each other's toes. Okay. Well, no, we already have mutable fields, right? This list of items is a queue, and it's immutable, but the queue itself is mutable, and I was planning to mutate it. So adding another mutable field is not really making a qualitative difference. Items handled is int is 0. Is that a thing you can do? No. Yes? Oh, this means you have, if you don't specify it, it starts as 0. Which isn't quite what I want. I want a way to say you just shouldn't specify it, right? I want like this. Yeah. And maybe a monkey itself should know, like, should have a function that's like I don't know exactly, that should, like, I guess basically what a monkey should produce for its turn is a list of pairs saying what items to give to what monkeys in that order, right? And it can update its items handled as it does that. Does that seems okay. Let's try that. This isn't really an accessor or anything, it's actually a function. Function do turn, no args, returns a list of pair of monkey index and item, right? So this is one reason it's nice to have these type aliases, is now this pair, instead of being unclear, is relatively clear what its two components mean. And I think we want, like, items dot as sequence, probably. No, because that won't empty the items. From the queue. We want, like, an immutable list builder, right? Yeah, that seems okay. Oh, man. I hate this type. Builder? Immutable list? Why can't I say builder? It's not new builder, right? No, it's builder. Oh, you don't know what immutable list. Okay. It's builder, right? Am I crazy? What the hell? Immutable. Yes. Yes. You said which one. Import it. But you don't know which one. It's right there. Can't access init? It's package private immutable list? Yeah, I don't want to new it. Okay, am I supposed to say val Brett? Is this? What am I? Why? What? Oh, am I supposed to put the dot here? Yes. This isn't how it looks in Java. You put the angle brackets after the dot and before the function name, which is an ugly place for them, but was needed for various syntactic backwards compatibility reasons, and I'm, I guess, not over the Stockholm Syndrome or something. Because this is obviously the natural place to put them. I'm just not used to doing it. And then we basically say... Like, I want while items is not empty. Let's say items dot first. How do I get? I want to like poll first, right? Oh, it's a remove first. Isn't what does Q have? Right? It's a queue. I mean, I can make an array deck if I have to, but I was trying to be less specific. There's first on iterable. There's poll. What does poll do? And what's the difference between it and peak? Remove. Poll. Okay, these are both the head. That's fine. I guess since I'm working with only the queue interface, it doesn't offer the double-ended queue operations. Sure. Add always goes to the end, right? Okay. I guess I'm going to say remove then. Item is, or let's say old, is this. And what's the order we're supposed to do this stuff in? First, we look at the number, we perform the op, we divide by 3, and then we test. Okay, so val post op, sure, is old. No, it's, oh, sorry, we're not, here we go. It's operation of old divided by 3. Right? Yes. So we can just call this new, in fact, since we can inline the divide by 3. There's not any new changes happening. First, I guess we are also saying items handled ++ here. Now we've got old and new. We don't need old anymore, right? In fact, inline it. Val recipient is if new mod factor equals 0, then if true, else if false. Yeah, that is a typo, thank you. Didn't actually rename it though. Rename to, yeah, that. All right. And we want to ret.add of pair of recipient and new, right? I think it makes more sense for items handled to go here. Not that it matters. Return ret.build. Seems okay, right? We've discharged all of our responsibilities in this function. Now, notice we haven't done any of the like modular arithmetic of figuring out what the right modulus is here, right? We're going to do that at a higher level. We're gonna get the number from the monkey and then trim it down to whatever modulus we're working in. The product of all those primes. In like run round or something we were saying, right? So let's say fun simulate rounds. Num rounds is an int and monkeys is a list of monkey. and it returns an int. Well, it could return an int, since we know that part 1 and part 2 will both just ask us to compute the same thing. In principle, we shouldn't know that yet. I only know it because I read the Stack Overflow question. And it would be more clear, maybe, more future-proof for it to return, what the monkeys are up to after this. But whatever, I'll just make it return an int. And are you allowed in Kotlin to mutate things that you've closed over in a Lambda? Reassign them? In Java, of course, you can mutate objects you have references to from a Lambda, but you can't reassign locals, which is a constraint that has saved a great deal of heartache by people who accidentally mutated things when they thought they weren't. You just can't make that mistake in Java, and it happens all the time in Python, and in Go they recently made it impossible, or harder, in the most common case anyway, to have that mistake. But you can still make it in other cases. And even knowing that that's a problem, you can still make that mistake all the time. It's just so nice to not have that issue. But here, I want to do it. Maybe it would be nice to, if I just had a, So, okay, let's compute first of all. Val LCM is monkeys.stream.map dot factor dot. There wasn't a product, right? I guess you can just reduce times, and that's not so bad, right? Reduce int times? Yeah. So that's the product, the thing we're going to need to work in the mod of. The modulus we'll need to work under. Can I say here monkeys equals monkeys? Is that legal? Can I say var here? Is that allowed? No. So you must not modify function parameters. Unlike in Java, where if you want, you can treat them like ordinary locals. Fine. So I'll just call this init monkeys, and I'll make a new thing called monkeys. But actually, I want a little bit more than that. I want to map copy, right? Not quite, because they'll have the same items, right? God, mutation is the worst. Copy dot, isn't there a with or something? No, there's some function. Oh, copy takes args, right? You can say copy. Can't you say items equals it dot items dot clone is now what I want? It's not, though. God. Q doesn't implement clonable. ArrayDec does. Fine. I will cease being parametric. So now we have a copy where we can change these monkeys as much as we want, and the monkeys that were passed to us won't be affected, which is important because in part 2 we're going to run the simulation again, and we want the same initial state. We could take the modified list of monkeys and run it the other 9,980 times, but I'm not going to do that. So I think I just want to say numRounds dot times. No, isn't it repeat? There's some function on ints where you can like do a side effect a million times, and I keep accidentally finding it, and this time I want it, but I can't find it. My gosh, there's so many options. I don't see any of it. What the hell? Kotlin perform side effects n times. This is not. These are not at all what I want. Iterate. There's this function called repeat that does something a certain number of times. Where is it? It's not on int. It's just repeat, huh? Okay. So what I'm supposed to do is say repeat numRounds a lambda. So here, can I just say like monkeys equal monkeys? Like I'm allowed to mutate it here, right? Yes. So this is the kind of thing that would be illegal in Java. But at the moment, it's what I want to do. So hooray for that. I guess what I'm supposed to do. Oh wait, all the monkeys are mutable. I don't need to make a new list. I just want one list of monkeys, and the monkeys in it are going to change. Okay. So I think I basically say monkeys, iterate over it, please. Yeah, I don't think we want to destructure that. Thanks. We're going to say val. I don't know. I mean, I guess we can just iterate over the results of telling the monkey to take its turn, right? Iterate over that too. Let's destructure it. I and I1, huh? What's the order? Index. And then item. Recipient, let's say. Item. Monkeys recipient dot items dot add dot. Why are you not error type? Unresolved type for array deck? Oh, what? Array to Kiwi. Okay, I see. This returns a Q. Well, yeah, that's true. So update the return type. Thanks. Items dot. I think we're supposed to say add. It should go to the front, right? But I guess I can say add first. And I guess here I should be more specific about which one I'm removing, right? And take turn. Now that it's actually a double-ended queue and I can be specific, I should be. Remove first. Yeah, that seems right. Add first of item mod LCM, right? Really? What? So why are you... Why are you upset expecting an element? Oh, I have a dot there. Operator is required on mod. So your complaint, I think... is that item isn't int? But somewhere else I did mod on an item, right? And it was fine? Oh, but new is an int. If I say int, are you going to be happy all of a sudden? Item is an int now. Whereas here, it's also an int. No, here it's an item which is like an int. Now it's also an item that's like an int. Okay. So what do you mean? Operator is required. Do you have a suggested fix? Of course not. And this is still wrong, even after I call toInt. Int.mod of other int. This is a function on ints. Is LCM the wrong thing? It's an optional... Oh no, that's what's wrong. Okay, never mind. Or else throw... Sure, we don't need to be clear. We'll know from the stack trace exactly what's wrong. I see. Cool. Is that it? It seems right. If we're running, so we don't have an off by one on the number of rounds, I think. So if we're running 0 rounds, we're going to do something 0 times, which means return the original input. That makes sense. And I guess... I'll just, like... return... Okay, so there was a day earlier where I wanted like top 3 of something, wasn't there? It was in common collect. What was it though? Iterables? No. I don't think so. I probably needed comparators when I was using it, right? Yes, comparators.greatest3 natural order. Okay, cool. So we're going to return monkeys dot stream dot map of it dot items handled collect with comparators dot greatest 2 on natural order item. And I assume this is going to return an optional or something. It returns a nullable object. So do I just have to say this won't throw up? Is that what you're mad about? Oh no, I have to multiply it. Reduce int times. Now wait a minute. Shouldn't this be wrong? Shouldn't there be a type error here? Because what if the list was empty and I couldn't multiply anything? Reduce? How the hell can this not be nullable? If there... Oh, okay. It just throws an exception. I thought the whole, like, thing with Kotlin was you weren't supposed to silently produce null pointer exceptions. All right, well, anyway, in this case, I was just going to double bang it, so fine. So let's say we're done. Part 1 is simulate rounds 20 monkeys, right? I assume something will go wrong here, but it'll be exciting to see how. It's a number. It's really the highest my bar ever gets. It's the right answer. Great. So let's commit this. Part 1. And also pretty much part 2, right? Since we know what part 2 is going to be already. You worried you might not ever get your items back. So worried your relief that the monkeys inspecting didn't damage an item no longer causes your worry level to be divided by 3. Ah, I see. So there is another little twist. Which is that you don't get the division. Stuff just goes up and up and up and up and up. I see. 10,000 rounds. This is why things really get out of hand. So same thing. We just need to add another parameter to our function. What the hell is this? It like didn't commit. The virtual machine or container was forced. What? Get fetch? Like what's our status here? Are things okay or are they not okay? Get. How do I compare to like? I guess get log is what I want. This is my main. Origin main is way down there. Oh, is this because of GitHub like leaking their auth key in the last couple days? But it was their SSH key, and I'm connecting via HTTP. I think. Maybe I'm not. But like, I don't know what the hell this means. The virtual machine or container was forced to something? Can't even read the error. So when I say commit, it says there's nothing to change, which is true. Oh, I haven't said push, that's why. Right. So there was some error here that was inconsequential. And the problem is that I haven't been pushing. Fine. We'll just say divisor is also an int. Oh no, but that's the thing monkeys are supposed to do. Oh man. It's not a thing that happens here at all. Okay. So we're going to have to map over the list of monkeys and monkey with them somehow. So this needs to, I mean, I don't know. I guess this is fine. We can just say val worry reduction factor int is 3. So we won't have to change our parser at all because it'll just get the default value. And then in main, we can just say run 10,000 rounds, but instead of monkeys, use monkeys.map of... Okay, and putting this inside of string interpolation is kind of psychotic, but it.copy worry reduction factor is 1. Right? And that should be it for part 2. That is too big. That shouldn't have happened. Huh. But I'm taking the item mod the LCM, right? Okay, let's put a line breakpoint here, I guess, and see if something weird is happening to our LCM, or what? Hello? Line breakpoint, debug. Okay. So what is, oh my God, 7 through a million stream operations apparently. LCM is like 9 million. That's more than I thought it would be. But not outside the realm of possibility, right? I mean, we could calculate it by hand. 17 times 3 times 5 times 11 times 19 times 2 times 13. I mean, that should be pretty big. 9 million or so, yeah. But I guess we are in the realm of like 9 million squared is 12 digits. That's too big to fit in an int, but not too big to fit in a long, I guess. So we actually got some integer overflow somewhere. This is a nice thing about Clojure, at least. One nice thing about Clojure is that the default numeric operations, I think, it's been a long time since I used Clojure, but I believe these days, as it has been for a long time, the default operations throw if they can't fit. And you have to explicitly ask, like, don't check if you want rollover or overflow to be silent. So I think I can just say, oh, here's a nice thing. I can just say an item is a long, and I think I'm set, right? Except I'm going to have to find some places that say like 2int and Can't be applied to long and int, but can't you just have 0 be... Are you really going to make me write 0L like it's 1995? Okay. Might as well make that a long as well, right? That's a long. 3L. This now needs to return a long. What did I say convert to long? No, okay. I thought you might guess correctly. Too long here. Anything else wrong? Comparators.greatest to what's the problem here? Ah, natural order, but this isn't of number of items. It should actually be int. How about this one? Too long. Should be long. Actually, can I say item type plus? Does that exist? I'm sorry, item plus? It does. Okay, so this is what I should have written to begin with. Too long. Okay, there's still a lot of places I have to write too long, apparently. But not as many as if I had used int throughout the program. Okay, I still see one more problems. This should be initmonkeys.stream. Grabbing its factor, which is a long now. So this is another, I mean, I don't know. Fuck, it's still negative. How dare you? Okay, so I guess what we can do then is inside of do turn, we can say this is our new number, right? And we can say also if it less than 0, throw runtime exception going negative. And I mean, this is not enough information to debug, but I don't need it because I'm going to put a breakpoint right there. And I'm just going to look around at what is the wreckage that has caused this. I don't need this one anymore. What? Oh my god, I'm reducing by int times? Should this be long? Was that the problem? Natural order of longs? I mean, number of items handled really shouldn't be... Well? I mean, it could be. I mean, number of items handled. We have 10,000 rounds. It's 4 zeros. 8 zeros is only like 10 million, right? Why am I counting 8 zeros? I don't know. Oh, because I'm multiplying two such numbers. But a monkey could easily handle like 3 items around or something. It could be, but it still shouldn't be over 4 billion. But like, I guess just in case, I'll make this along as well. You wouldn't think so, right? Sure, this returns a long. So I guess I need a breakpoint here, actually, because it's not the monkeys going negative. It was actually the result? That's very suspicious, isn't it? What's the square root of this? Where's my REPL? Can I have a REPL? I mean, I can eyeball the square root, right? I mean, 3, 6, 9, 11 digits. So it's 5 digits long? I mean, that would require a single monkey to handle, like, not all that many items on average actually, right? Because if every monkey handled one item per round, that would be 10,000 squared, which is 100 million. And if they each handled 10 items around, that would add in 2 more factors of 10, which is 100, which would be 10 billion, which is outside the range of int. So yeah, it is sort of believable that this could be the answer. I guess I'll write it up and see what happens. Too high. Yeah, not a surprise. Okay. So I guess what we do then is, like, right here, let's just print line monkeys, right? And, like, let's have a look at what's going on. We got these 8 monkeys. Ooh, look at him. He's sure got a lot of 11, so he is handling a lot of items every round. Okay. Where's items handled? Oh, it's not in the toString because it's not from the primary constructor. Well, fine. I'll move it. Take that. Can I just say, like, put this in the constructor? Move to constructor? Yes. Now if I run this again? Okay, and I can also get rid of this whole also, I guess, right? I mean, I know I could have opened up this monkey and looked. It's only handled 48 items in its entire life. Wow. Oh, but that's because we're in part 1 right now, right? Yeah. Okay, so if I say run again... Okay, now we're in part 2? Yes. And again, this guy's collecting all of the... Okay, so there's like 2 monkeys doing all the work. Most of the time, it looks like. Wow. Well, no, look. These guys are these 4 monkeys are doing all the work, and right now, these 2 have all the items, and I guess next turn, these 2 will have all the items? Interesting. Out of curiosity, which monkey is the one that squares? I assume it's one of these 2. It's the one who cares about 13. That's this one. What? Okay, I guess just like old times 17 applied enough times, I guess, is something that happens a lot. Or times 7 or whatever. Interesting. Because the 7 and 11 both multiply and both get... No. This guy adds. But this guy multiplies, and he takes a lot of operations. So we're computing like 17 to the power of 200,000 or something with this guy. So sure, it should get large. But these two numbers, you know, this is about 200,000. It's 5 zeros. Ten zeros is 40 billion, which is out of the range of int, but well within the range of long. And in fact, if we look, of course, at the number that we guessed, 1,000, million, billion. Yeah, it's okay, 32 billion. I thought closer to 40, but sure. So it makes sense that like the factor of those two would be about what we came up with. But why is something wrong here? I mean, we could... Maybe I read the spec wrong. That's one possibility. But I don't think so. Hello? Could we go to day 11? $10,000 rounds. First of all, is that what I wrote in my program? Yes, num rounds is 10,000. Okay. Oh! I see the problem. No, I don't. I was like, wait a minute, I forgot to copy the monkeys here. But this is where I copy the monkeys. And I clone its items. Oh! But I didn't copy the items handled. I didn't reinitialize that. So items handled is going to be too big, right? I hate mutation. It's so bad. But okay, items handled should be replaced. Anything else that I'm missing? No. But wait a minute. No, that's not right. That's not the problem. Because items handled on these monkeys, like, I'm never mutating the monkeys that came in. Right? I take the init monkeys. I compute the LCM. And then I get new monkeys by copying them. Let's put a line breakpoint here and see if I have somehow screwed something up on the way into this function. I don't exactly want a line break, do I? I want like... I want a break when we enter this, I guess. So now we're in part 2, right? Yeah. So how are these monkeys doing? This guy has the same 3 items he started with. Items handled is 0, and we've set his worry reduction factor to 1. So the monkeys look uncontaminated, right? Yeah. What else? What other mistake could I have made? Huh. So I've got these new monkeys. They all look very, very pristine. Oh, I stepped over all the work. Oh, cool. Wow, you can actually put a breakpoint there while it's running. That's kind of a surprise to me. So I just, like... Recipient 4, item 2. I mean, that's... We clearly haven't messed that up. I mean, I can test this on the test input given to us in the problem, if I want. But I imagine I'll just get the answer is wrong, and I won't know why. He politely used an example where the number was too big to fit in a signed int. So I can't really complain that I didn't notice that. I mean... And there's a lot of hints, by the way, about it being too big to fit in an int. It's ridiculous. You need to find a way to keep your levels manageable. Huh. Like, I could take these 4 monkeys and make them a test input and run on that. But... I don't really believe this is going to help me debug, but I guess I don't have any better ideas at the moment. Because I don't know what might be going wrong. So terminate here. And let's just create a file called day test. No, it has to be a number, doesn't it? I don't know. No. Daytest.text. And if no, don't put that in get, thanks. If I go here, where's main? So if I take this, comment it out, and replace it with... Oh, but this takes an int, doesn't it? Okay, very funny. Rename to day 26.text. And just like run it. That's a number. What was the expected result for the test? Not this. Is it close? 3... Oh, right. I said 2.7 billion. Whereas my result is 3.1 billion. But I get part 1 right, don't I? 10,605? Yeah. And of course I get my real part 1 right as well. But I get part 2 wrong. That's so weird. I'm not... It's not easy to like debug this because I have no idea where it's going wrong. I have a process that works for a small input. It fails for a large input. Now there are some ways I know it could fail and I've accounted for those, right? I've converted things to longs. I don't think I had to, by the way, well, I think I did have to for the items as well, because the least common multiple was a lot of digits, right? Whatever it was. And so they conceivably could have large items. Although, wait a minute. Give me back my real input. Oops. And just stop here. Or, right? Because I want to see what... The items the monkeys have are not very large, right? This is in date part 2, yeah? 10,000 monkeys with a worry factor of 1. So the monkey's LCM is 9 million. So we really did need a long there. Because 9 million squared is as big as we potentially could get. And that doesn't fit in an int. But the monkey items are actually all very small, which is really weird to me. Well, no, right. They're small because we're reducing them mod whatever. So it's computing a bunch of different things that are equivalent to 11 mod 900 million, which still seems hard to do. I don't know. Something seems wrong with like the items the monkeys are getting somehow. I guess a way that we could be going wrong here that we weren't before is that before all of the modulus operations were doing nothing. Maybe. Right? Because we were dividing by 3 so much that, well, I don't know. I can't prove it by looking at this. But that seems plausible, right? So maybe there's just something wrong with how I do modulus? Or how I computed the least common multiple? Or my understanding of how modular arithmetic works? Least common multiple, multiplying them all together, should mean that divisibility tests by any of those mods should still be correct, right? Because like, let's say our two numbers were 2 and 5, right? Those were our only things we were testing factorization by. our least common multiple would be 10, and we'd be doing whatever to numbers, adding, multiplying, whatever, and we get numbers like, 75, and we'd say, oh, reduce that mod 10, it's 5, but we still haven't changed whether it's divisible by 2 or by 5, right? The last digit is all that matters for that. And that's what you get when you mod 10. And the same thing holds for every other prime, well, indeed even co-prime, even non-prime, but we don't need to worry about that thing. And for a larger number of them, it should also hold, right? If you take something that's divisible by 7, let's say, and you reduce it mod a number that's a factor of 7, you get something that's still divisible by 7. So I think that's all right. But am I doing the modulus wrong? I mean, we have a number that's guaranteed to be, well, we know there's never any overflow in this step, because if there were, we'd be throwing a runtime exception here, right? Wait, what? Oh yeah, new is operation of this, and then do something. So if the operation made it overflow, we would know. And then we choose a number, one of these two, based on the divisibility test. Seems right. And we handle the LCM down here. We take all the monkeys and we look up their factor and we multiply them all together. And we get this, which, I mean, I guess just for fun. How do I copy this? Copy value. Just out of curiosity, if I said prime factors online, prime factorization calculator. It's loading a little slowly. Oh my god, this place is killing me. It's some PHP program. Let's try another one. Prime factors decomposition. Prime factorization calculator. Oh, that one loaded fast. So if we take a look at this, it's a 2, 3, 5, 7, 11, 13, and 17. And that seems right. Those are 17, 13, 17, 3, 2, 5, 7, 11, 19? Was 19 in that list? It was, right? Yes, it's here, but it doesn't show up in this tree for some... Oh, 19, I see. Okay. So that looks right. It's a sum of all the smallest primes up to 19, or the product of all of them. So we computed the LCM correctly. And then here, we're modifying the monkeys that we copied. I know right now numRounds is 20. We haven't stepped into the one where it's 10,000, but we ask the monkey, hey, what number would you like to throw? And it says a quadrillion, zillion, bajillion. And we say, actually, let's reduce that mod 900 million, or, sorry, 9 million. That all seems pretty cool. I didn't get confused about the order of these, right? This is a monkey index and this is an item. Yeah, that all looks good. If I got those wrong, we'd be seeing a lot of index, array index out of bounds exception, or whatever Kotlin's version of that is. I don't know. And as I mentioned before, I don't even know how to debug it. We're using the worry reduction factor correctly, right? I know it's 1 in our list of monkeys, but we're using it here, right? Oh! I just left this in. I added the monkey reduction, or the worry reduction factor, and I didn't fucking use it. But since it's mutable, it said, "Oh, you wrote to this, sure, you know." Ugh. It didn't warn me that no one was ever using this. All right, run again. I mean, this is 3,025 billion. I think we had 36 or 306 billion, so this is lower than our last one, which I think means it could possibly be right. Ah! Okay. What lesson should I learn from this? Don't get partway through making a change and then get distracted and don't finish making it? Sure, but that's not very actionable. I mean... You know, look more carefully at the... When you have two things that are similar and one of them works and the other one doesn't, obviously you should look at the places where they differ. And I thought I had done that, but I guess I forgot about this don't divide by 3 thing because it was so easy and obvious, and I added the worry reduction factor, and then I was like, problem solved. Although actually this is a val. When this is gone, shouldn't something have warned me this is never used? Oh, but it's used, but in a write-only way. I wouldn't have thought that would count. Huh. Oops. Okay, anyway, we can get rid of this whole also branch thingy here. Clause. Anything else to change? I mean, this is not ideal, but I think it's fine. Get rid of that. And this I would sort of like. On multiple lines. This is how Google Java format would do it, right? That's the way I want it. I definitely don't agree with every single decision the Google Java format makes. But I really love not having to think at all about how code is formatted. And what it produces is code that is readable, and makes reasonable choices for things, even if, as I said, I don't agree with all of them. Just like being able to shrug your shoulders and let the formatter take care of it every time and get something readable that is exactly the same as what someone else would produce is way more important than the actual specific formatting. And so I got used to how Google Java format works. And this is what I want, but I don't know. I don't know how to specify it to IntelliJ because there's all these knobs you can twiddle. And Google Java format intentionally has 0 knobs. Or it might be a very small number, but like it probably lets you specify tab width or something. I don't know. Anyway, I guess we're done. Commit. Part 2. We're not doing part 3 right now. And this, let's just delete this. Not roll back. How do you... Like, I want to revert it. I want to close it. Delete, I guess, is fine. All right, we made it. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.